Good morning guys. Today we are going to perform experiment amplitude demodulation. Okay. So the board we are using here is the RX 433 receiver board. That is nothing but 70072 receiver. This is the receiver board. Okay. For demodulation purpose, and this is the transmitter board for the modulation purpose. So we are going to use these two boards today. Here we will do the transmission and here we will do the reception and the demodulation. For three transmitter board, and here it is the receiver RX transmitter and the receiver board. This is the transmitter board and this is the receiver board. Okay, we are transmitting through the wired communication channel. You can see here. So let me do the connection for you. So this is the connection here. Let me show you the connection. Okay, the output is connected to the double sideband and the carrier is connected to the sum, and here and this sum. Here we are transmitting through the wire communication channel. Okay, this is transmitted, the signal, the modulated signal. Here it is modulated signal. Okay, so it is transmit through the wire communication, and here it is receiving. Okay, here the receiver signal is given to the rectifier input and the rectifier output. This is the rectifier input. You can see the output of the whatever the signal you are receiving, and this is the rectifier output, and this is the low pass filter output. So we have here we are going to use AM demodulation with the help of low pass filter. Just do the verification. Let us verify the connection again. Okay, it's fine. Let's proceed with the experimental part. So this is the double sideband demodulation. So this is envelope curve demodulator. So this, okay. So let us start with the procedure. So let us start with the procedure. So activate AM in the transmitter board and see the function generators in sine wave 500 Hz, VPP is 3.8, DC is equals to 0. So here what we are going to do is, so open the software CommSlab. And the CommSlab here, continue. Okay, go to the function generator and make it as 500 Hz and VPP is 3.8. Make it 500 Hz. Hertz and VPP is 3.8. 3.8. Okay, so here what we are going to say is we will just open the oscilloscope and make it 500, and before doing this just activate AM from here because it is AM modulation. So here whatever the thing we are transmitting, here whatever the thing we are transmitting, we will check on channel Y1. So this is what channel Y1, pure Y1. Take the single shot. Okay, this is what we are transmitting. Okay, so this is the transmit amplitude modulated wave. So after transmission through this channel, wired channel, so here we are receiving the data, the modulated waveform. Okay, so here we will check the channel y1 what is the modulated, what we receive here. So we will make it 500 micro. Okay, so channel 1 only. So this is what we received. This is what we received. Okay, so what we missed, the connection here is we will ground these two boards. Okay, so now let us check the curve y1. Let us check the curve y1 oscilloscope, make it take y1 here. Okay, it's the same thing what we have transmitted. Okay, this is the receive signal, amplitude modulated receive signal before rectifier. Okay, this is before rectifier. So the same thing we'll check. We connect to the white rectified output. So what we do is rectifier, and we'll check rectifier output now. So what is the property of rectifier? The half of the waveform will be clipped off, half wave rectifier. So make it y2, curve y2. So it will be half of the waveform is clipped off. Okay, so let us make it 5 again. So if you see here, let us take the dual mode here so that you can easily identify. Okay, so here you can see something in blue, and this is full wave, and here it is half wave. Okay, so rectified output, rectified input and rectified output. So let us go back to y2. So this is rectified output. Okay, this is rectified output. So same thing, we will just take the low pass filter from here. We will take the low pass filter output in the channel y1. Go to the channel y1 again, a single shot here. So this is what you can see, the sine wave. So this is a sine wave which is after low pass, which is passed after the removing the higher frequencies. Only the lower frequencies are passed here. So higher frequency is nothing but the carrier frequency. The carrier frequency we removed. After removing the carrier frequency, we got the lower frequency, that is the message signal. So this is the first part. The same thing we will do with the for the single sideband. So second part is synchronous demodulation. Synchronous demodulation, what we are going to perform here, it is we will use the multiplier here. Okay, multiplier in the low pass filter, where in the previous case we have used the rectifier to just remove the half part. Okay, now what we have here, f is message frequency is 15 hertz, sorry, 1.5k, and VPP is 2 volt. Okay, and DC is 0. So we'll just check. So we are doing AM here, it is already clicked. Go to the oscilloscope and let us see what we are going to transmit. This is our transmitted version. This we are going to transmit. Okay, here we are transmitting. Okay, so here the transmitter, it is connected to the AM here. Okay, and this is the new thing, synchronous. We are using the same carrier what we are going to use in the modulated thing. So the carrier is input to the multiplier. Okay, so input to the multiplier is carrier. Then open the oscilloscope here. Let me connect this one to the y1 before multiplier what we received signal. Just open the synchronous curve y1 curve y1. Okay, this is what we received here. Okay, so this is the amplitude modulated waveform which is received through the wired channel. Okay, so next we will see the multiplier. After what we are multiplying here, the received signal synchronously we will multiply with the message carrier. So channel y2 we are using for the multiplier output. Okay, this is a multiplier output. The two signals are multiplied, the carrier frequency and the amplitude modulated waveform. So here you can see this part. Okay, let us go to the, so this is modulated multiplier output. So demodulated waveform we are using again low pass filter to remove the higher frequencies here. So this is the much better version, right, from the previous. So synchronous is much better than envelope detector. Okay, so you can draw the waveform respectively. So this is synchronous demodulation. We are going to perform the same synchronous demodulation we are going to perform with this for single sideband. Okay, so here we have connected from double sideband to the single sideband. Okay, these two are connected here. Okay, and we are just giving the single sideband output to the summary. Okay, so this is the output here what we are going to transmit. This is the single sideband output. Okay, you can see the spectrum also here. This is the spectrum. So we transmit this here, and again we will just check the input. We will check the input here with the help of oscilloscope. It's curve y1. This is curve y1 what we have transmitted using the transmitted port, and this is the received version of single sideband. So next what we are going to do is we will connect the multiplier to the multiplier output. We will connect it to the multiplier output, and simultaneously you can see the spectrum here. Open the spectrum. See the spectrum what we received here. So the frequency here is 10 kilohertz, and 11.6. So let us connect to the multiplier output. Oscilloscope, this is the multiplication output. So we will make it curve y2. So this is the multiplier output, you can see. Okay, just remove it and connect it to y2 to see the to see the low pass output. This is the low pass filter output. Okay, so you can see the simultaneously the spectrum here. The spectrum. This is the spectrum. Okay, 1.5 kilohertz. This is the message frequency approximately. Okay, this is So this is how much? 1.6. Let's see, 1.6. So how much was the message? Actual message, it was 1.5. So this is the demodulated output for single sideband. So this is the multiplier output. This is the multiplier output. Okay, and this is the spectrum for multiplier output. Okay, so this is around 1.6 and this is around, let us bring this marker here. So it is 15.2. okay, so this is the multiplier output. In case you have not taken, just draw it.